Okay, number 54 in your classwork for similar triangles. Gives you this problem. So an archaeological team is excavating facts from a sunken merchant vessel. So they have a probe that is approximately 4,800 meters directly, or traveled this distance, 4,800 meters, at an angle depression of 69.3 degrees. So they want to know how far the probe is below the ocean surface. So we want to know this vertical distance. And so we know if the ocean surface is horizontal to the ocean floor, then we have a pair of alternating interior angles here. So this is 69.3 degrees. And so in this triangle, right, our opposite side here that we're trying to find, this height, can be found with a relationship of sine. So we have sine of 69.3 degrees is equal to opposite, which is h, over our hypotenuse, which is 4,800 meters. And so multiplying by 4,800, our h will be 4,800 times sine of 69.3 degrees. So our h is, plugging into our calculator, 69.3, that is 4,490.13 meters is our unit. Then when the probe reaches the ocean floor, what will be the horizontal distance between the ship and the probe? So the horizontal distance, this x value, we can solve using cosine. So the cosine of 69.3 degrees is equal to x adjacent over hypotenuse, which is 4,800 meters, multiplying by 4,800. So we have x is equal to 4,800 meters times cosine of 69.3 degrees. So our x distance is, plugging into our calculator here, 69.3 is 1,696.68 meters. Then part C asks, if the probe travels horizontally at a speed of 5 meters per second, how long will it take the probe to reach under the ship? So if it's traveling this direction at 5 meters per second, we know the relationship of rate is distance equals rate times time. So our time can be rearranged by dividing by r. So we know that distance divided by rate is equal to time. And so our distance is this horizontal distance that we found in part B, which is 1,696.68 meters divided by 5 meters per second. And this gives us a time of 339.34 seconds.